Good morning, everyone. My name is Reda Kabaj. I am the VP of the Global WtERT Council. I am very pleased to welcome you to the Global WtERT Congress 2023 here at the beautiful city of Hangzhou. I want to thank you all for coming to the Congress. I know all of you guys, some of you came from so far, and I'm very pleased to welcome you and to attend the Congress. So first of all, I want to introduce Professor Themelis, who's gonna provide introductory remarks, for the Congress. So Professor Themelis, could you hear me?
Yes, I hear you.
Okay, so yeah, we're very, we welcome you, and could you please, provide, your introductory remark?
Thank you very much, Reda. Dear friends and members of the Global WtERT Council, welcome to the 2023 International Congress and best wishes for a very successful conference. I regret that because of a health problem, I cannot join you at this very important meeting. However, the program will include a virtual presentation by me and Mr. Reda Kabaj on the history, current status, and benefits of the WtERT technology to humanity. WtERT organization was created at the beginning of the 21st century. It's the only international academic industry organization, and by now represents about 1/2 of the Earth's population, the countries which belong to it. The growth of the WtERT technology in this century has been phenomenal in the 21st century, especially in the country hosting this 2023 Congress. By now, China's WtERT power plant capacity is greater than that of Europe, America, and Japan combined. Also, the Chinese WtERT power plants, some of which you will visit this week, are truly state-of-the-art, both aesthetically and functionally. The participants to this meeting have done a lot to develop and promote the WtERT technology over the globe. The Chinese contribution, in particular, and potential for developing nations have been recognized by my passing on this year with thanks the leadership of the Global WtERT to Professor Huang Qunxing of Zhejiang University, with whom I have collaborated several times in the past. Also, as you will see this week, Professor Huang and his colleagues at Zhejiang University have created one of the most powerful WtERT research, development, and education centers in the world. The WtERT organization was the first academic group to promote the application of WtERT and the phasing out of landfilling in many parts of the world, including North and South America, China, India, Abu Dhabi and Arab Emirates, Ethiopia, and Serbia. There is still more to be done to decrease landfilling and its major contribution to methane and climate change, which has been catastrophic. We of the older generation have done what we could do. The future is yours. Good luck, and thank you for attending.
Thank you so much, Professor Themelis. We are now introducing Professor Huang to join us and provide us a remark.
Professor, can you hear me?
Yes.
Okay, thank you very much. Unfortunately, you cannot be here. And today, it's our great honor. And we have representatives from 13 countries to be here and to join this Congress 2023. And it's my great honor to take up your throne. I would like to say to continue your legacy about waste to energy. And I would like to give you a very brief introduction about waste to energy research works in our university. And tomorrow, we will bring you to the big facilities we have built on waste to energy researches. And here is my personal, very brief CV. I have been graduated from Zhejiang University, and I have been working on waste to energy for more than 20 years, and has been a PI of a lot of the national bigger projects. And also now I'm senior expert of the national R&D research work on waste to energy. Here is stories between me and Professor Themelis. We have been our university has been engaged in waste to energy GWC for more than I would like to say 12 years, and we have carried out a lot of cooperations on waste to energy, and also with Professor Han Wei. At that time, he was working on Quanta, and we have been there for more than a lot of years until 2019, before the COVID. After that, we have been trying to continue the WtERT Congress, but unfortunately, because of the policy of the virus policy. So until today, we have been so happy to gather here, so tomorrow I will give you more detailed about our research works in our research center at Qunxing Huang place. So here is some brief information about what we are doing here in our university. And the target we are dealing with is including municipal solid waste, industrial waste, and hazardous waste. We have been on this kind of the waste for more than 30 years. And most of our work was focused on the energy and also the environmental aspect. We are dealing with the waste from the aspect of the energy, and also we are taking care of the pollutions from the aspect of environmental protections. So we combine this together. And a lot of the research work was focused on improve the combustion efficiency, and to develop new technology and the philosophies for the treatment, like gasification, like pyrolysis, like that. And this is a technology we have developed over more than 25 years ago with fluidized bed incineration technology. And now it is widely applied in China, not only for municipal solid waste, but also for the sludge and also industrial waste, especially sludge and industrial waste. And it was awarded as a national award in 2006. And also we are dealing with new technology for the sludge drying, and also for the sludge to improve the efficiency of the sludge incinerations. And tomorrow you will see our facilities in our research center, Xinjiang. And also we are working with hazardous waste, like medical waste. We have contributed a lot during the COVID-19 virus situations, and by developing new incineration technology to deal with medical waste, pharmacy waste, and also like that. And this technology is also good. And also, you know, in China, we have a lot of the rural areas, people living in the village. So we developed a small scale incineration systems to take care of this waste. This is located in Jiangxi province, which was supported by a national NGO fund. And also it is a demonstration in Indonesia and for the waste incineration in the small place near the Jakarta. And another things we are recently doing is about our industrial waste, like waste tire and waste plastics. And now we are using pyrolysis technology to take care of all this waste. We are converting them into oil, high quality oil, and the PTX enriched oil, and also like carbons for the recirculating of these things. And this is the piloting systems. And if some of your professors will stay here, I would like to bring you to our demonstration plant. It's very big. We are working with the largest rubber maker in China to reuse the black carbon and also to improve the recycled product qualities. And also another thing, we are working with the United States EPA for all the dioxin monitoring, online monitoring technology, and it's now has been applied in a very big plant in Hangzhou and in Ningbo. And it uses laser technology to monitor dioxins online, continuously online. It's very difficult technology, but we are already, it is a machine working. And recently, and under the support of our national research program, we are working on the AI technology to apply AI technology to improve the combustion efficiency. This is research works we are carried out in the last 2 or 5 years. We are working with Alibaba. They have industrial clouds department. So we are improving using imaging technology and also neural networks to improve the combustion efficiency of the various waste, like industrial waste and also municipal solid waste. And this is a key technical and equipment project which was supported by our central government, and I'm the PI of this project. It is over 20 million RMB. The overall fund was over 20 million. So we are working with Everbright and Zhejiang Group and build the largest 1,000 tons per day facilities, and it now is under operating. And this project was highly valued by our central government. And then this is a new technology we are developing with Zhejiang Group to be further processing the municipal solid waste to convert it into valuable fuels like RDFs. And then the RDFs can be submitted to cement and or other countries. And then the quality of these fuels was very good for electricity generation and also for the heating, and also very suitable for burning in the circulating fluoride bed. Here is this is the largest CFB incinerator in China for municipal solid waste incinerator. You can take a look at the steam parameters. It's very high. This is the highest steam parameter. It's very great works for the future. This is for the future of waste to energy. And the overall electricity generation efficiency currently can reach approximately 30%. It's very high for the waste incineration systems. And the steam pressure is very high. It's close to 8 megapascal. And also, this is a demonstration plan project. And if you have chance, maybe you can go take a visit of this. And also recently, we also are doing research work on helping build the generalist. And if this is the EI included general, and if you have any research outputs, you can go to this journal, which is organized by our university and with the Publicity University of Hong Kong. Thank you. And this is a very brief introduction because we will have a chance to meet tomorrow and to see our facilities. And during that time, I would give you a more detailed introduction about our systems and about our research works. And hope you will enjoy the Congress. And I think the most important thing for us to gather here is for the future of waste to energy. And I think it's not only to improve the efficiency, not only, but also we have to be low carbon. And now a lot of the works are working on how we can reduce the carbon and how we can increase the incineration residues value. So that's the future of the waste. And also I hope from this conference, and I noticed a lot of professors comes from the developing countries, and I hope the experience of China and also from other German or from Korea can be helpful for the waste to energy industrial business in your countries. And thank you very much, and hope you can enjoy this Congress.
Thank you so much, Professor Huang. It's a very impressive presentation. It's and we are very honored and very, among all our members. Like we congratulate you to become the president of WtERT. Again. So now I'm going to introduce Miss Rulin Zhu, the international coordinator of the College of Energy Engineering at this university. She's going to provide us, a keynote presentation about the international development of our university, Zhejiang University.
Okay, thank you for the introduction of Rita. Dear distinguished guests and scholars and dear students, I'm Rulin Zhu, the international coordinator of the College of Energy Engineering of Zhejiang University. And today I'm going to give you a brief introduction of our college. My introduction will be given in 3 parts. The first one is a brief brief information about the College of Energy Engineering. The second one is our research profile. And the third one is our effort towards international cooperation. Part 1 about CEE. Currently, by March 2023, there are 2,000 students at our college, including 1,000 master and PhD students and around 900 undergraduates. We hold a team of 159 faculty members and staff, including 3 members of the Chinese Academy of Engineering. And apart from that, we also have more than 40 visiting or adjunct professors. The college consists of 5 institutes. The first and biggest one is the Institute of Thermal Power Engineering. And Professor Huang's team also belongs to this institute. And other 4 institutes are process equipment, of refrigeration and cryogenics, of power machinery and vehicle engineering. And last one is Institute of Thermal Science and Power System. These 5 institutes represents the main research fields of our college. The part 2 is our research profile. You can see by the numbers in 2022, our research funds has over 400 million yuan, which is roughly around 55 million US dollars. And CEE is committed to the major needs of the country and the frontiers of the discipline. So over the past decade, we have won numbers of national awards for our main research advances. And in the past 5 years, CEE has been undertaking more than 90 major research national projects. Under the background of carbon peak and carbon neutrality, our energy tech innovation research at Zhejiang University can mainly divide into 5 parts. There are renewable energy, clean and efficient utilization of fuels, energy storage and hydrogen, carbon capture, utilization and storage, and the last one is smart energy. We strive actively to build high-level innovation discipline platforms at CEE, and currently we have 11 national or ministerial level discipline platforms, including the State Key Laboratory of Clean Energy Utilization and National Center for International Research on Clean Energy Utilization. Our efforts are also building provincial and university level discipline platforms. These platforms help to promote multidisciplinary intersectionality and integrated resources and accelerate scientific research construction. And at the bottom of this slide, this Baima Lake Laboratory, Key Laboratory of Clean Energy and Carbon Neutrality of Zhejiang Province, has newly established in 2022. We also open to the university, the cooperation between university with enterprises, school, and local governments. So a number of joint research and development centers have been built in this aspect. So the last part is our global global cooperation. This is a brief map of our main global partners. You can see our partners not only include famous universities, but also have those major institutes. We actively holding international activities. Like in the past 5 years, CEE has hosted 19 international academic conferences. And since the pandemic, we adopted online and offline combined combined effort for holding these activities. The international education is also a key focus of our college. We doing a lot of efforts in funding students for international exchanges, building an international contingent of teaching faculty, and also promoting international double degree programs. And also we established international joint fund in school level. And at last, we offer international master and Ph.D. programs for international students. And this program, the master program of energy and power engineering, is specially funded by the Chinese government. Also, the international training workshop has been held 6 times since 2016 and have trained 151 participants from 27 countries. And this workshop of this year is now conducting now from October 25 to tomorrow. So this is all about my introduction. If you want to learn more about us, you can visit our official websites and the university level international media. Thank you for listening.
Okay, good morning to everybody over there. Greetings to all the people from the WtERT organization and to Professor Themelis. And we are very grateful in Colombia for being able to be part of this international group of people. We haven't been able yet really to have a waste to energy systems in Colombia, except by one that we have in the island of San Andres. But we are very, we think in the coming future, the ideas of waste to energy will become normal in our country because we are striving for that. And the national government in the new plan for the next years put in writing that landfills cannot be used as a means of disposal, but they think they can manage that only by recycling. So we have to explain to them that not only by recycling can you do that. You have to use also waste to energy and also organic handling. So we believe we are now in a nice time to start working on these matters. I belong to the local society of engineers with Mr. Walter Ospina. We prepared this presentation for you. The matter we are going to deal with is the barriers we had found in our country and also in Latin American countries to really develop waste to energy systems. So I'm going to present now. Start with the first one. The title of the presentation is Barriers to Development of WtERT Technologies in Colombia. We have a WtERT Council in Colombia since 6 years ago with the collaboration of Professor Themelis, who had come to our country a couple of times, and he has helped us a lot. Next. Okay. We are basing this presentation in our experience because we have been in many places in the country, in many meetings, trying to explain to people about these waste to energy systems. We had found several barriers. So I'm going to explain to you what we experience. Right now in our country, we have the state of Antioquia, and the state of Antioquia is planning strategic planning for the coming years until 2040. So we introduce into the projects that are included this waste to energy initiative, which we call technological parks, environmental parks for the regions of the state of Antioquia. So we are presenting this to the local authorities. The idea is to go from the normal activities they have, recycling and putting the waste on landfills to something as it can see on the right of the slide. Next. Next. Okay, first barrier we find is the lack of knowledge of this technology in general. People really don't know what this waste-to-energy technology means. Of course, they have a rough idea, but they don't know the components, they don't know the need, they don't know the economy, the flows, the space required, the resources. So we have to illustrate as much as possible about this. But what they see is people wanting only to recycle and people protesting any technology development that is not recycling. So in our country, the only idea is zero waste and recycling, and also landfills. But they don't have in their minds waste-to-energy technologies. So we have to explain to them continuously about this. Next, please. Okay, we have now to deal with the waste management companies, the companies that pick the waste from the houses, take them into trucks, and then to the landfill systems. And they also operate the landfills, and those companies, they already have their business, which is well established. They earn money by that. They don't want any technological change that involucrates having additional facilities. So we had to really overcome these difficulties with those people. They don't accept waste to energy because they know about investments. They don't have the money. They have trucks and they have landfills. That's what they have. Following, please. Next one. Okay. Now, the politicians and the authorities are in general working by themselves. So we had to try to establish relationships with them, with the governments in the cities, in the country, in the regions, with the people who administrate, trying to meet with them, explain to them all these things. And they are planning changes, but they believe they don't have the money for any change. So what they want to do, as I am telling you, is keep recycling and improving on the separation and the recycling systems. But they don't believe that they have to go all the way to the complete treatment. Although there are some instances in the country in which some planning is being made. Basically, in our city and in Bogota, they are including the waste-to-energy facilities in their plannings, but they don't see where they are going to get the money for that. Next, please. So the idea is that the initial investments and the operations expenses are too high for this type of systems, but they don't know the numbers. They haven't done the calculations. So we had explained to them what the investments are and what are the calculations for the expenses, for the energy produced, and so on. But it's difficult really to explain to people about economics, because if they don't have the budgets, they don't see the need to really enter into the economical situations, and the budgets are not there. Next, please. Next, please. Next one, please. Okay, so we have prepared curves in which we have done conceptual design to understand how is going to be the operation expenses and the investment required for this, and we put that into how much you have to sell the electricity according to the way you proceed to really recover the investments. And we come out with numbers that are well within the possibilities, because right now electricity in our country is quite expensive. So perhaps if they really pay attention to this, they will be able to see that by selling electricity, they are going to recover most of the investment on these systems, because now the electricity cost is high in this moment in our country. So the situation is better in that sense than the situation like 3 years ago, because the electricity prices have raised 3 times lately in our country. Following on, please, next. We had even calculated how many plants we need in our country according to the several options we have, how much money we have to invest to solve the whole situation in our country. And we have come to figures which are between, let's say, $2 billion to $7 billion for the whole of the country. And if we distribute that in 20 years, and we understand that the GDP of our country is about $6,000 per habitant per year, then we distribute the amount of money in 20 years, and we come out with the idea that the amount of investment we are going to require per habitant is really low. It's not too high. So it's not too expensive really to invest in waste to energy, because we are going to solve this problem of waste. So we hope by using these figures, eventually they are going to understand this. Next one, please. Ahora, now, the legal framework is not good for us, because the Ministry of Housing is the one in charge of designing the waste systems, the waste policy. And what they do is to make some kind of a system based on recycling, trying to give better positions to the recyclers, trying to distribute the money among them. So they have invented a very complicated system to recycle and distribute the money coming from the recycling. But it has not really worked yet. But they still keep doing that and thinking that that's the way to proceed. So let's see what happens in the future. But now the legal framework is not favorable to waste to energy. Next one, please. The electrical companies could be interested in this, because this could be a source of electricity. But the electricity price is going to be somewhat high, but less than the price of making electricity by using natural gas, which is about the 25% of the electricity of this country. Our electricity is about 75% coming from hydropower. So it's less expensive than the electricity coming from natural gas. But the situation is getting such that the price is going up for all kinds of electricities. These slides here show pictures from the only waste-to-energy plant we have, which is in the island of San Andres in the Caribbean of Colombia. But I must tell you that this plant has been built since 6 years ago, and they have not been able to get it to work. Only in the last year, they completed the installation with the separation unit before the incineration, and hopefully it is going to start in this year. But we had spent 6 years doing nothing yet in that only plant we have in our country. Next one. Environmental licensing is a problem in our country because it's very complicated to get a license. Here I show you a picture of the mayor of the city of Bogota, which is the capital of the country, when she inaugurated the idea of having a waste-to-energy facility in Bogota. So everything seemed to be perfect because the mayor of the largest city had decided that they are going to have the waste-to-energy facility over there. But then it began to get complicated, And so far, they have decided to study the innovation ideas related to that, and until they resolve that, they are not going to do that. And this mayor is finishing her state in the city in this year. So I don't believe they are going to do that. The next mayor said that they are going to build a methane burning and energy recovery in the waste site, but they are not going to do a waste to energy facility as was initially planned. And this is because of the difficulties of environmental licensing and getting the permits. Following one, please. Next. This idea of zero waste is very prevalent among many people in our country, especially in the universities. They believe that you don't have to build any facilities. You need to educate people in the idea of zero waste and recycling. And they don't understand, as it's shown in this graph, that when people start progressing, they spend more and the amount of waste increases. So this idea of zero waste is not really practical, but they still have that in their mind. Next one, please. We have a problem here because the tipping fees are really low in Colombia. In Colombia, a tipping fee is of the order of $10 in the total per ton, as compared to tipping fees of the order of $50 to $100 in the United States of Europe. And of course, if those tipping fees are so low, then you don't get any money out of that to help with the expenses of any waste to energy facility. So we had to change those ideas in our country and explain to people that you have to pay for handling the waste more than the amount you are paying right now. Next one, please. And there are not policies really at the municipal and state level. They don't understand really what the advantages are of this idea of waste to energy and of working with the organic materials in a correct way. So in our country, we tend to be reactive in our legislation and not very creative. So this is a big barrier. Following one, please. Next.
Are you close? Because
this is the closing one. This is the closing one. The closing one is that we have to deal with environmental groups, which is a real difficulty, because the environmental groups are every day more powerful. And so we have to discuss with them, explain to them, invite them to meetings and so on, so they understand really the advantages of all this. So basically, this is my presentation.
Thank you so much, Enrique, for your presentation.
Okay.
Yeah.
Thank you very much.
And we're sorry to keep you awake at this late time. And so Yuri, welcome, and we're very proud to have you here. So you can start making presentation.
Good morning. Good morning, everyone. It's a very pleasure to be here to present about the Brazilian scenario of waste to energy, what we are doing here. ABREM is a national association of waste to energy, a non-profit. We present some companies around the world, multinationals, like Hitachi, Babcock, Veolia, the leaders of waste to energy, some of them. And we have some projects in developing. We are a partnership and represent WtERT in Brazil. And we have 50 academic researchers in a group, published articles, papers about waste to energy. And ABREM is a tool to improve the waste to energy sector. It was created 5 years ago, and 41 members that represent total annual gross revenue of 54 billion years. And we are one of the largest waste management associations in Brazil. And we represent companies like machines and equipment manufacturers, construction, EPC operators, concessionaries, trading companies, engineering, and consulting companies. Don't have to push the button. Okay. And we are member of the Global WtERT. And this is our members of a brand like Babcock and Grupo WtERT from Daniel Sinsiki. He's the director of Grupo WtERT, and we'll make a presentation today. And we represent Hitachi, Veolia, some of companies, and Solvay, and international companies, Sutico, sorting, RDF producer, and Loasti, and some international companies that are part of the waste sector. And here are some partners of a brand moving forward. The problem in Brazil is 40%, about 39.5 to be exactly, go to dump and non-sanitary landfills. And 10 years passed, and the problem is the same, but we are increasing the quantity of waste in landfills. Goes to 25 million tons a year to 30. We are growing to put in non-sanitary waste dump sites. And waste-to-energy can change this reality. Sometimes in Brazil, they create a landfill, and the operator don't make a good service, and this landfill became a non-sanitary landfill. With this new sanitation law was approved by 2020, all the municipalities have to sign concessions contracts with a long-term contract. It's very important to develop waste-to-energy projects. We are prohibiting short-term contracts and the tariff to consumption bills to give a guarantee in a project finance to the banks to get the financial to be the guarantee of the gate fee. You can create a regional blocks of construction municipalities. And the national waste management targets was approved in Brazil last year. Have the target to reduce, to eliminate, of course, non-sanitary landfills and waste dump by next year. I think that's not possible, but they are trying to do it. And for 2040, 15% of waste-to-energy plants and 34% recycled material in organic composting by digestion, and to reduce landfill to 52%. This is the target for waste-to-energy plants, 1 gigawatt of capacity by 2040. We are in late because next year we expect 311 megawatts, and we have nothing. We have one plant contracted, and will be developing in 2 years under construction. And this study about greenhouse gases was made by United Kingdom government together with Brazil, the Brazil Energy Program, UK. They found this reduction of emissions from greenhouse gases, the methane emissions. Brazil assumed that in COP26 to reduce 30% of the methane emissions by 2030. And using, for example, we produce 82 million tons a year of waste, municipal solid waste, and by using 21 to 31 million a year in waste-to-energy plants, we can reduce 28.9% using waste-to-energy plants. It's a good strategy. And to maintain pledges of United Nations. And for each ton of waste treated in a waste-to-energy plant, 1.5 to 1.7 kilograms of CO2 equivalent can be avoided from landfills in Brazil. In Brazil, 50% of our waste are organic and food waste. And methane is considered the second biggest driver of anthropogenic climate change nowadays. Some countries consider methane to be a dangerous pollutant that are killing 1 million people die prematurely every year due to exposure to ground level ozone. These super emitters of ozone, I will show you the next slide. Brazil and another country started committing to reduce, as I told you, and landfills are an important source of methane, a powerful greenhouse gas that, according to IPCC, has a global warming potential 86 times greater than CO2 over a 20 years horizon. And waste to energy in the 28 Brazilian metropolitan areas with more than 1 million inhabitants have the potential to avoid emissions about 6 million tons of CO2. And it's equivalent or 1.8 billion in 30 years, the operating of the plant, a waste to energy plant. As you can see here, this is the annual methane emissions of, you can see by the industrial revolution start to grow the methane emissions. And the blue line here, this blue line, is the 20 years global warming. And if you doesn't do nothing about that, what's the problem you have in the future? The temperature will grow very fast in the same color. You can see it's the problem. The methane is the principal objective of United Nations now to reduce greenhouse gases in the world. As you can see here, the super emitters using satellite data, NASA discovered using spectrum cameras to see the super emitters. This study was published last month, a new study, using almost 3,000 photos detecting using the satellite of Carbon Mapper, the NASA, and 2 satellites of Europe. They made this study. And what you can see here, Brazil, the problem is landfill. And even if 72% of our methane comes from the agriculture sector, is not a super emitter, not concentrated. These super emitters are causing disease because they can damage the ozone in the troposphere. And you can see gas, oil, and coal is one of the largest methane emissions. China have problems with coal, for example, and Russia and some countries there, gas. And this is what we are searching for. This data is open. You can access carbonmapper.org, and you click in data, and it's online. You can show, you can see these photos online in your computer. It's a free access, and this landfill are located in São Paulo. It's the biggest one. They are emitting 7.7 tons of methane per hour. It represents, but they are declaring to the MDL to receive carbon credit. They are declaring that they are capturing 94%. But the reality is they are capturing 44%. Some of landfills are capturing only 30%. Dr. Themelis alerted us 10 years ago that in the report of 50 report of IPCC, that landfills, you only can capture about 50%. But the reality is worse than that. And we can prove that now with those photos. As you can see here, is another landfill in Brazil, 1.2 tons per hour near São Paulo city. This is the problem in São Paulo. As you can see, the big city, 20 million inhabitants, and see the size of this plume of methane. The landfill is very short. It's like that, landfill. The plume is 10 or 20 times more bigger than the landfill. And you can see here, it's in China, this landfill. One of the last ones that you have here, but it's one of the biggest. They're emitting 15.4 tons per hour of methane. Qunxing landfill in Zhejiang. I can pronounce it well, sorry. And this is study we contracted GGSAT from Canada. They have these spectrum cameras more advanced than NASA have. They have the personal, the satellites I think that they have 4 satellites taking this photo from private companies and governments. China can contract them to take these photos using these special cameras, and they took 113 measurements via satellites in 22 landfills in Brazil, and this is the result about our study. They are emitting 7 times more methane. If you compare that, they are declaring to receive carbon credit, because most of those landfills are here. All those landfills, they capture methane to burn the flare, but most of them, 9%, are generating electricity. And they say, this is energy recovery, very beautiful. Let's invest them, let's reduce greenhouse gases, but it's not a reality. A landfill is a big producer of methane. And waste dump is not the biggest producer of methane, because the methane can be in contact with the earth, liquefaction, and it's not going to the atmosphere. But when you cover the earth, you can produce 3, 4, 5 times more methane. And landfill is not a solution for a climate change crisis that you have now. And this satellite was built been built by NASA, and very advanced. It's a state-of-art imaging spectrometer. We measure the greenhouse gases, methane, and carbon dioxide from space. And the new one is the carbon dioxide, and everything will change next year when the satellite will go to the space, because it's possible to measure in real time the problem about emissions. Every year, you can change the inventories of emissions and greenhouse gases in the countries and to find new solutions to cut these emissions. These infrared 5G prints invisible to the eye, for example, can pinpoint and quantify strong greenhouse gas emissions and accelerate potential mitigate efforts. And let's move forward. Some projects of Brazil that you have now, it's 256 megawatts of capacity. And Mauá is a project Group Lara. Daniel will talk about this project. Barueri is under construction and to be operated by 2026. Rio de Janeiro have a project, Santos, Brasília, Consimares, but we have a potential that I will show you. A federal bank, Caixa Econômica, supported by the World Bank and IFC, BYD, AFD. They have a federal fund to structure concessions to be bought and to put together landfill, recycling facilities, waste-to-energy facilities, biodigestions, composting. And you are convincing them to put waste-to-energy in a lot of those projects. And they have already 80 approvals to hire consultants, and 16 municipalities have projects in progress now in Brazil. And this is our potential in Brazil we can construct 130 plants with 20 megawatts of capacity to invest $28 billion in Brazil, using those metropolitan areas that have more than 1 million inhabitants that represent about 47% of the waste that we are generating in Brazil. Thank you very much.
Just stay with me. Thank you so much, Yuri, for your presentation. And I'm asking you if you have some questions to Mr. Yuri. Please welcome. You can ask him. Is there any question? Yeah, Dr. Hani from WtERT Jordan.
Thanks for the presentation. Actually, nowadays, the satellites are widely used in monitoring landfills. However, specifically for methane, you need certain sensors to be fixed there, multispectral or something like that. just have, I'm wondering regarding the uncertainty in these measurements. Sometimes you get cloudy weather, sometimes you get rainfall, and how are you dealing with such uncertainties in this? And nowadays, drones being employed in measuring with better accuracy, I think, than satellites. Thank you.
It's a good question. And clouds can, and the wind can change these plans. And for us, we are taking the photo that have the huge, the quantity, because they have a variable quantity. For example, carriers go to 7.7 hours to 1.2. 1.2 didn't represent the reality, but 7.7 represent, because we don't have wind and the conditions are good to see the methane plum in the atmosphere. And you are taking the higher quantity to measure. But the discussion we have this discussion, and to be exactly, we have to take a lot of photos, and we can quantify using we can calculate everything and can divide for the number of the photos. It's a good mathematical method. It's very simple, just to calculate a medium emission, and with a medium emission, we get this result, about 7 times more emissions in landfills in Brazil compared to what they are declaring to the IPCC, received credit carbon.
Good, thank you. Is there any questions from the audience?
I have a question.
Oh, yeah. Good, yeah. Very good.
Okay.
Thanks.
Thank you. Nice example Brazil is giving us. I have a question for the presenter. How were you able to change the way of approaching waste-to-energy systems in the last years? Because in the last presentation you gave us in Colombia, there were not so many projects in the future. What were the reasons for the nice change?
The reason is to show the society the problem, to continue landfilling waste and to receive more credit carbon. Because if you can avoid those emissions, 6 to 8 times more using waste to energy, because methane is 86 times more dangerous and more strong than CO2. And it's best to burn the waste than to landfilling. And this approach will give more arguments to us to convince the authorities, the government, about the necessity to avoid waste from landfills, to divert waste from landfills, and to use that. You can use compost, of course, you can use waste to energy, you can use digestion, but as you know, to the big cities, waste to energy is the best solution.
Okay, thank you.
Thank you.
Okay, so any questions? No more questions? So I'm gonna ask my own question. So you may know that China has developed a lot of waste energy, within the last 4 years. How come, that Brazil could learn from the success stories of China, in terms of research, academic research, how to foster academic research, and also, the bringing, industries, to look for the market in Brazil, in order to accelerate, the development of the waste energy technology, because it's good to look for a good success stories, and implement it in your home country.
I think that you can put together the industry, the companies, the academic in the same level, in the same space. It's why you create a brand with WtERT, with the focus on the market in the industry, with the academic together. You can have good arguments, studies, researchers, supporting the public policies in our government, to show it's not what I think that is right, it's what science are saying that's right to do with our waste. And using this academic approach and putting together with public policies, you can change what we are doing there in association, a non-profit association, with a board that you have in a brand, representing the companies and with a separated and independent academic group that is WtERT. We have internal rules to work with this structure and to focus in public policies. It's what we're doing, but some companies is not so, for example, compliance, a CEO of a company cannot maybe discuss with a senator, a deputy, with a national secretary. It's not so good because maybe corruption problems is when we are association, we are a group that say, Yuri, go and represent ourselves there. Another thing is that you can organize the ideas in the same level, because one company that have an idea here, another company have another idea, and they cannot have a good approach with the government, and association can do it. And I think that a brand will change everything in Brazil in the next years. And I recommend you, all the countries, to create national associations of waste to energy. It's good to invite companies to support with money every month, every year, and to give a decision, a support decision to the public policies and to help them to take good decisions. Thank you.
Indeed, indeed. Well, thank you so much, Yuri, for your presentation. And now we're gonna move to the next speaker. Thank you so much. Appreciate it. So our next speaker is Professor Thanos Bourtsalas. He's the acting director of the Earth Engineering Center of the Columbia University in New York. So he will not be able to join us, unfortunately, but he made a video recording presentation. Okay, so just to give you a little bit background, that WtERT was founded at the Earth Engineering Center, and Professor Themelis founded this institution.
And
also,
I would like to thank you very much for inviting me to present at our WtERT meeting. I wish I could make it in person, but luckily, with the use of the technology, I can at least present and discuss, hopefully in the near future, with you the activities of the Earth Engineering Center of Columbia University. The mission of our center is to conduct research and education on the use of materials and energy for sustainable development, with a core emphasis on the preservation of land and as well as water resources. Also, a core focus of our center is to disseminate this information by means of publications, presentations, and the web. The guiding principle of our center is that responsible management of renewable and non-renewable resources must be based on science, best available technology, economics, but also the external environmental costs. Several years ago, Professor Themelis had developed the hierarchy or the expanded hierarchy of sustainable waste management by considering the different levels and the different technologies and techniques that can be used in order to properly manage our waste materials. And at that time, obviously, and recently, we had also this 3 R's and 4 R's concept: reduce, reuse, recycle, and recover. So this expanded version apparently implies that when we talk about all these waste materials or technologies, we can actually talk and focus on 2 broad categories: materials that have a value in the market and thereafter can be recycled, can actually provide a good economic value, and some other materials which, for technical reasons as well as for some limitations that we do have in the market, cannot be recycled or recovered in terms of materials. So for these materials, the post-recycled will have 2 options: either to recover energy, with the combustion-based systems being the dominant methods and systems in the world, or landfill all these wastes and consume land, but also emit significant methane emissions. Quite recently, we had the introduction of the circular economy, which implies that wars come to wars. We can talk about recycling, and obviously we have to have a core focus on the upstream and midstream operations of our supply chain. As per our experience, however, we do know that recovery and energy recovery specifically plays a core part of advancements in sustainable waste management of our nations. That is why, in our effort to provide some scientific arguments on the limits of recycling, we actually visited all these some recycling plants, 6 sophisticated and advanced recycling plants in Europe, and we collected primary data. We developed material flow analysis and life cycle assessment in order for us to understand the boundaries of our systems. All these plants, the 6 plants that I mentioned earlier, some of these plants are focusing on the recovery of materials. Some other plants are focusing on the recovery of an alternative fuel that can be used in the cement manufacturing. One plant is an integrated system where they have built a recycling facility followed by a biological treatment operation and then a dedicated waste to energy plant to process the non-recyclables. And another plant in actually the southern part of Spain, which have actually a core focus on the recovery of high quality from the organic fraction. On the recycling stage, all these plants operate with a state-of-the-art equipment, including disc screens, but also optical separators, which has also the capacity to separate specific type of polymers, of plastic materials, real time. So when we put down all the numbers, and this have been graphed on the y-axis, we have the contribution of the specific materials, which are actually here in the different colors, total plastics, ferrous, non-ferrous, the 2 types of paper and cardboard, glass, organics, non-recyclable paper and plastics, abbreviated as NRPP. So when we put down all these numbers, system 1 sends all the non-recyclables to a landfill. So I mean the main revenues come from the total plastics, but they have actually a negative contribution from all the non-recyclables, but most importantly, a significant greenhouse gas effect that comes also from the non-use of the non-recyclable materials. System 2, 3, and 4 focus on this recovery of the alternative fuels or the non-recyclable fraction for the cement manufacturing. So again, the main contribution comes from the total plastics, but also in these specific plants, and as attenuated, they have also a contribution in terms of the revenues. A key for the economic viability of all these facilities is to secure a contract of at least 20 years with the cement manufacturers at a price of between $20 to $25 per ton. Then we have system 5, which is actually the system that I mentioned earlier, the integrated approach where they have built the recycling plant, biological treatment and waste to energy plant. And this plant is actually by far the most profitable and has also significant savings in terms of GHG, because obviously, as we're going to discuss also slightly later, we have actually the highest diversion of materials from landfills. And also this system 6, it has actually a very good innovation in terms of utilizing the organic fraction, where actually they have approached farmers, which actually in proximity with this specific region, and they have secured a high quality organic material, in which case they can provide a better quality fertilizer for the market. Unlike all the other materials, which especially system 1 and 2, which send this organic material to a landfill, but they are actually paying for the disposition, because according to the European regulation and the recent amendment, these materials cannot be considered even as a compost-like output. So specifically for the case of plastics, when we talk about these 7 broad categories, and according to our analysis, when the discussion goes to the recycling, we can really talk down to about 3 to 4 materials, namely polypropyl, the mixed film, high-density polyethanol, and the PET materials. All the other materials, for technical reasons and some limitations that we have in the market, are not recovered. So all in all, this was actually the synopsis, the abstract that has been also published by the conference of the WtERT here in the US, hosted by Professor Castaldi at City College. This abstract says that apparently this system 5, again, this integrated approach is by far the most profitable in terms of net revenues, but also indicates the highest landfill diversion. Also, a recent study was published actually last week, where we actually did a thermodynamic assessment on the different approaches on waste to energy plants. First of all, we had actually electricity only plants, the use of heat in different modes, starting from steam condensing down to the use beneficially of this heat for district heating operations, but also a novel system that we assessed on the use of exhaust heat for desalination purposes. According to this thermodynamic analysis of the first part, the exhaust steam utilization, either for heating or for desalination, all these systems have actually an efficiency in terms of useful energy that can go up over 65 to 70%. Unlike the electricity-only plants, which actually indicate an efficiency which is actually down to about 15 to 20%. So obviously, the best practices imply that the use of exhaust heat increases efficiency and should be also considered in the design stages. Also, the use of exhaust heat for district heating purposes is also part of the Paris Agreement. And the second part of the study, where we focused on the techno-economic assessment by considering semi-quantitative criteria, namely the fresh water scarcity of cities, the limited fuel supply, the restricted land, waste quantity, waste quality, energy prices, existing infrastructure, regulatory support, public acceptance, technical expertise, as well as economic conditions. And for us to understand where this combined waste-to-energy desalination plant can be considered, and we found that apparently the European Mediterranean region, apparently my home country, Greece, is actually a very good location, along with all this Mediterranean coast, which actually get down to the French Riviera, as well as the Spanish region. Then also Persian Gulf and East Asia are actually the top destination, including China, Japan, and Korea. And also island nations have actually a fair advantage, especially on the fresh water scarcity and limited fuel supply, but also on the economies of scale. Also, recently, we also did a study on the plastic waste exports, not on the global level, but specifically on the US. As you know, in 2017, China had actually instituted a ban on the imports of plastic materials, and this obviously affected significantly the recycling markets in Europe and the US. In the US, which is actually shown on the left side, we had actually the exports of about 2 million tons, even more in several years, of plastic materials, different types of materials, mainly to China and as well as Hong Kong. After the Chinese ban, all these materials were actually redirected to Asia, other countries, as well as South Asian countries. So mainly Indonesia, Malaysia, Philippines, as well as India, but also we had some cases like California, which was also the top in terms of exports in both periods, pre and post, also relates to the very big population, followed by Illinois, Texas, as well as New York. So all these places, instead of them building their own infrastructure, they prefer to redirect the flows to even more poor countries, which obviously they don't have the capacity to process and treat properly all these plastic materials. And when we did also a life cycle assessment along with a techno-economic part, which is actually shown in this last bar towards the end of the graph, obviously, a domestic treatment of our materials, which implies that we will have to increase significantly the recycling rates from a low 9% of plastics recycling, which is now in the US, we'll have to go this up to about 70%, and the rest should be processed in recycling plants, an expensive system, but obviously will be associated with significant benefits. But also a partial increase in the recycling rates and an increase in the waste to energy rates, talking again about processing of recycling, will be associated with benefits as per scenario A. Also, since also 2015, right after the Paris Agreement, we have actually a very strong collaboration with the United Nations and the Center of Excellence for Public and Private Partnerships. And now recently, last week also, we extended this collaboration for the next 3 years. And we developed actually some guidelines for public and private partnerships specifically for waste-to-energy projects on some, considerations that should be taken into account in the very, very beginning of the projects to make sure that all these projects will comply with the Sustainable Development Goals, the 17 SDGs, but also with the circular economy principles, under this umbrella of the public and private partnerships, which, as we know, associates with significant reductions in the risk of the investments. So the top priority is actually that the waste-to-energy facilities should only process non-recyclable waste. State-of-the-art technologies must be embedded in WtE plans to ensure compliance with stringent pollution standards, and adopting the 5 desirable outcomes, which I'm going to explain right next, of the public and private partnerships for the SDGs could help governments and the industry adopt better legal but also policy frameworks to ensure best governance practices in waste-to-energy projects. So this, table is actually a summary of these 5 outcomes, which namely the very first priority is actually access and equity. Ideally, these projects must provide service to low-income communities, vulnerable groups, and also improve equity as well as social justice and plan for long-term access and equity. The second part, obviously, is economic effectiveness, but also because of these projects are mainly supported also by the by public actors, also fiscal sustainability, in which case a top priority as per the United Nations guidelines is to avoid corruptions and encourage transparent procurement and in general processes with the use of technology, maximize long-term economic as well as financial viability by also enhancing employment but also economic opportunities for the local people. Also, environmental sustainability and resilience, with the second being very, very important in regard to the attenuated changes that we will see in terms of the climate. So obviously, all these systems must be built and be also resilient in order to be protected from, future phenomena and extreme phenomena. Then also replicability to make sure that this project can be scaled up and replicated in other nations and cities within the same region or elsewhere. And also the backbone of all these systems in terms of deployment is the stakeholder engagement. In the very, very beginning, well before the design stages of the project, the consortium must make sure that all the stakeholders coincide exactly on the same conclusion. That is why it's very, very important to conduct surveys and ask the stakeholders what do they think about this specifically. Also, if you are actually interested, I have included also a hyperlink from the specific guidelines that we developed, and in the appendices we have included several case studies around the world on how waste-to-energy projects approached and reached actually advancements in each of these individual outcomes. So when the discussion goes to the effective governance, the key elements to advocate sustainable infrastructure, transparency of processes, but also stakeholder engagement, is strong regulations, including fiscal incentives, regular inspections, and zero tolerance on corruptions, similar to what we saw in the case of China, where we saw this phenomenal growth in the construction of waste-to-energy plants with a massive support from the public entities, both from the federal but also down from the city level. As I mentioned earlier, very, very important exactly to map the interest and the intentions of the different stakeholders, which include public, private actors, also academicians, non-for-profit organizations, and in some cases we have some interconnections there, and we have also some private companies and private actors who are actually spreading disinformation in this specific field. So that being said, it's very, very important not only to try to understand them and provide arguments, but also education and public outreach programs. Also, a top priority is non-discrimination in the hiring processes, empowering women and also vulnerable groups, ensure also the fiscal sustainability of the projects, because as we discussed earlier and as we know, we talk about very big investments, which obviously will put a burden on the fiscal budget. Replicability, but also will be associated with significant revenues. Replicability and scalability of projects in other regions, also very, very important. And congratulations to the WtERT group in China, who actually organizes all these training programs and capacity building programs. It's actually very, very important to transfer knowledge from the private sector to the public sector, the governments, also to the global south and different regions who are actually interested, but they do not have the tools and the capacity building to build all this infrastructure. So congratulations again. And also a very, very important direction, which also is being definitely being pushed by the World Bank and financial institutions, is actually the result-based financing. At the moment, we do have both green bonds as well as blue bonds that have been introduced by the World Bank in order to reduce the risk associated with waste-to-energy investments. And all these, investments can be attached to a specific result, not in terms of economy, but maybe in terms of access and equity, in terms of reductions in the greenhouse gases or other indicators of the particular interest on a case-by-case project. So with that, thank you very, very much again for giving me the opportunity to at least present online. Congratulations again to all the activities and the great initiatives that you are doing. Keep up the great work, and hope to see you soon in person. And also, if you have any questions or concerns in regard to what we discussed today, please let me know and just send me actually an email. So thank you very much.
Well, warm thanks for Professor Bourtsalas for his presentation. And as he mentioned that the Earth Engineering Center has been will provide the next report of the PPP, and I'm inviting all the WTM members to join and support the EEC to help co-author this report and provide the information insight from each of your countries, more specifically in emerging countries, to help providing more information. And one of the aspects he mentioned about the international training workshop, that several participants from emerging countries are joining this training workshop to help them understanding the technology, how to develop such a project. And we will attend the closing ceremony tomorrow at the afternoon. Okay, so I'm gonna move to our next speaker, which is Professor Young Shi-Seo, who is the head of WtERT Korea hosted at Yonsei University. He's gonna present us today the history of waste to energy technologies and recent issues in Korea. So welcome, Professor Young Shi.
Thank you. Anyway, thank you very much for inviting me, Professor Huang, and also Ella. I'd like to introduce some of the history of waste management as well as waste to energy, I might say utilization in Korea. So just to show our experiences, it might help you for your, the present or future directions on your country. Also, I'd like to say very much pleased to see old friends, especially this one and somebody else. And also, I've seen many new friends. So I'm very happy to be here. Let's see. Yeah, that's why I'd like to introduce myself a little bit in the beginning. So I just retired from the university officially, and I was former president of the Korean Society of Waste Management. And also I engaged this WtERT networking maybe 15 years ago as a head of the Korea. Okay, next, just this one. Oh, okay. Yeah, I was a chemical engineering. I did my PhD with gasification of coal about 40 years ago. And then I moved to the Atomic Energy Research Institute to develop some of the engineering for waste, nuclear waste, and also stabilization of nuclear waste. And then I moved to the university The reason I'm telling this, I was a chemical engineering to develop new energy, renewable energy, gas out of coal, but I shift to the waste sectors when I was a radioactive waste, actually nuclear waste management research center. And yeah, okay. Two fingers. And just, yeah, my lab used to be developing a thermal treatment processes for very poor fuel or waste and this kind of thing to, produce different types of energy. And then while we do, utilize this process all the time, we have to consider air pollution control. So I did the research on air pollution control. And also at the same time, we have to recycle some of the residue from those processes. So that's why I did a lot of research on waste management, especially the thermal process developing for the country. At the same time, I worked with the WtERT from 2010. Also, one time, maybe 7 years ago, I was in charge of waste to WtERT Asia as a vice president of the. It's originated from China. Next one, please. And why I do work on the waste management field about 20 years ago. When I was in US EPA, they asked me why do you research on mercury? Because one of the emission, the hazardous, the emitters, pollutants. So I started my research on mercury to read my whole country. We didn't have such research at the time, 20 years ago. So I asked the policy papers to develop, their strategies to how to manage mercury from the emission up to the waste, mercury waste. So that's one of my field in research. So I was worked for the UNEP for writing the global assessment report to the mercury management. So I have a two field, waste to energy and mercury. Okay, I quote this figure from the very old textbook, the principle of waste management. Everybody knows this in this room. So reduction is first step of generation. And also we have to recycle as much as possible. Then leftover should be burned. And then landfill. So there's a priority, 1, 2, 3, 4. Okay, we are, even in Korea, we are talking about many different policy and strategies with the different words like green growth, carbon reduction, or whatever. But these principles are not changing. So this is the first page of my lecture in the class, actually, for the student. So these principles are not changing, but with the priority of the different options. And also, all options are very much inevitable, vital components. It should be use all of those, the options, practices. Next. So this table shows our legal changes in Korea. See, up to 1986, we didn't manage the waste that much, not by the the principle as I introduced before. So in 1986, the government put laws, waste management law. I must say this is the first time we implement such waste management principles. Okay, so-called maybe integrated waste management concept. So the reason I'm telling about this law is, it's a lot of effect to the waste management, especially waste energy. I show the history. Of course, we have a lot of activities or even legal law changes for focusing on the resource circulation, recycling, 3 R's, 4 R's, whatever. And also, I'd like to very briefly introduce a couple of policies which he implemented very much effectively later. And then recently, the government's put a new law, the so-called Frame Act on resource circulation, but now they changed the name, like circular economy promoting law, so something like that. Okay, next. So I show a couple of the policies which we got success. One is the polluter payment concept. Okay, the producer must pay. Okay, so we call volume rate garbage, I think, charging system. So every household must buy the bag which is priced back from the supermarket. Otherwise, you cannot throw it. Before putting the waste into that priced bag, you may have to segregate which are recyclables, the metals or plastics, even the food waste. Food waste, we have to buy designated priced bag only for food waste, or you have to put some weighing machine in each house is put into that food waste. The same concept for the other the municipal solid waste. So by this system, we can well segregate recyclable, combustible, and also food waste. And also, at the same time, we can reduce those waste. The one example at the time, it was applied in 1995. We have to pay a fixed amount of tipping fee. Okay, every house is certain amount, maybe $3-4 a month or something like that. But after changing this system to volume-based the tipping system, I must say, my wife just spent only $1 or $2. Okay, so that means what? The waste has been reduced. Okay, next one, please. And the other one for the, I think this system, for the industrial waste, we so-called extended producer's responsibility. So every item, such as a TV, tire, batteries, and those kinds under this system. So manufacturer, provider, seller must pay in advance to the government. The government will distribute those money to the recyclers. Okay, so after at the end of the year, they just they counted. Okay, how much percentage of, because in the beginning they got promised and they paid them to one of the governmental subsidiary company, and then it makes reduce the generation of industrial waste as well as the recycling properly. Okay, next one. So now we have around more than 200 items under that EPR system. Okay, they relate to WTE. This is the history of the system changing. I think, as I told you, the waste management law is a very big impact to the waste to energy utilization. So after this law, the governments follow this incineration priority policy. Okay, so next figure will show we installed so many incinerator after this time, 1990s till maybe 2005 or 10. And then the next one was the waste to energy policies, 2008. The government's pushed to utilize more RDF, SRF. Okay, so that was the two times of big, the impact effective the system. Okay, next. Yeah, of course, this where we utilize thermal conversion. Of course, for biological waste, we generate biogas, but this combustion, incineration is one of the conventional technology also not utilized. And as a new technology, gasification pyrolysis are the another options. Okay, next one. Okay, this is briefly showing how many incinerators we constructed. from, okay, maybe around 1990s, okay, to 2005 or so. Just few incinerators, of course, constructed within after 2015. So finally, we got around 20,000 tons per day of the waste burning. Okay, but most of them are just stoker type, stoker type of incinerator, and just few crude ice bed. And also we utilize gasification melting facilities, maybe eight facilities or 9 facilities. Okay, so totally around 20,000 tons of the waste are burning. Next one. And this is about history of the SRF. As I told you already, the 2008, the government pushed to utilize more RDF. So many manufacturing facilities were built, and also the power plants from the SRF. Next one. This is a gasification. So we did a lot of R&Ds, but not well commercialized. You know why? It was economically feasible. Also, a lot of technical efforts must be put in. But I did one of the research for the little bit bigger units, like 8 tons per day as an R&D step. So it was good. We can utilize a gas engine to generate the power from 8 tons per day. Actually, SRF, because it's pre-treated. So if you pre-treat the waste, then it's quite better to could get gas by gasification. Actually, original schedule was to build 80 tons per day unit. This is a real commercial unit in one city, but the government's a little bit. This is governmental funding, so they were a little bit worrying about, okay, if you put bigger one, if it failed, okay, a lot of trouble. So we just finished up to 8 tons per day unit for gasifier. Okay, next one. And there's a pyrolysis. Of course, we did a lot of research on pyrolysis, especially for plastic, plastic researches. And then 2018 or 2020 up to now, the political papers, the governmental parties, very much stressing on this plastic to oil by pyrolysis. So it's going to be a good market, I guess. So now, but already 20 companies are in competition to develop. But that is the scale is around 10 tons or 20 tons per day units, not big one. But there's a limit to make a bigger size. And I did one project recently, is developing commercial scale biomass to oil project. I built 20 tons per day units now. Biomass is a fluid ice bed, and also good cleaning system for, as you may know, tar and such things. But anyway, the biomass is much easier than the waste. So we developed the biomass, actually byproduct, not real the biomass. So that is in operation now. So that is one of the biggest one. I must say, is 20 tons per day, even including the plastic pyrolysis. Okay. Okay, this is a brief history of waste management. Actually, previous speaker and I, wrote one of the papers with this trend. So in 1982, just before the law that I said, was waste management, the landfill was 96%, so totally landfill. But that landfill is not sanitary, it's just open dumping. But after the law, the government pushed to install many incinerator, and also same time sanitary landfill. All the landfill changed to sanitary, not just open dumping types. And then also I didn't write here, but many sewage water treatment system as well. Yeah, but in my opinion, one of the reasons why we can do in this time, our economics were growing much fast. So we can the government can put a lot of money for, this public, the waste or water treatment system as well. And then the second, that's why I said is a first movement of waste to energy technologies in this period. And the second one, I said utilization of SRF at 2008. So now these are household waste cases. So 13% landfill, 5% incineration, around 6% of recycling. So I just, from my curiosity, I try to calculate how much greenhouse gas has been reduced by history, okay, of those such activities. This is just, I draw it. So, see, in 1982, because landfill was a measure, about 25,000 metric tons of the greenhouse gas emitted. But right now, maybe around negative around 50,000 the CO2 generation from the waste management, the activities, utilizing different options. So, actually just commercial power plants, the coal power plant, 600 megawatt, will generate every day 10,000 metric tons. Okay, so maybe eight or seven or eight, the greenhouse gases from the power plants got reduced by history of waste management. Okay, next. Okay, you know this figure well, so we can achieve the circular economy at the time, the carbon neutral. We do follow the principles of waste management. Okay, reduce first, recycle, energy recovery, and then next. Okay, I took this figure from the Ellen MacArthur Foundation. She drew this kind of curve, nowadays. So we have to go circular economy. I move to the next slide. Also, the country nowadays, this is the issue. How can we achieve the circular economy? So maybe governments nowadays stressing on the recirculation again, even though we got 60% of recycling, more, because this is a good word, good to the public. Public will like it this way, right? Even you can get more votes from the cheaper you're stressing. So, but what I'm going to say is they are not clear in recognizing the role of waste to energy. Okay, even though we have been doing well the waste management. The next one. Okay, this is again I quoted from that MacArthur's draw, so-called butterfly diagram for circular economy. Okay, we have a maximize this maybe wing of a butterfly. This is all recycling, maybe technical, mechanical, and also biological. So we did. This is a good picture, but what I'm saying is, okay, still we do maximize the recycle or recoveries. There will be leftover. Actually, in this figure, they say it's a big leakage. Okay, leakage. There will be leakage or residual part leftovers. So that has to be recovered by energy. This is not my figure. It's her figure. And then landfill. So what I'm saying is, we have to maximize this part, but still there will be leftover. So what we have to do with this? We have to recover the energy. So it's, as I said, go back to my principle. Okay, waste energy or energy recovery is one of the, inevitable options. We have to use that. Okay. Otherwise, maybe we can get a waste crisis, also some leakage. I used to say in Korean, waste out of waste is a leakage. Okay. Next one. So let's go back to our history again. So we did a good up to this point. Of course, we tried to utilize RDF to energy, but we got failed. It's not because their goal was that time, we're going to reduce up to the 1 or 2% of landfill. So that means what? If SRF utilization is can reach to the properly, you can reach to them. But I used to nowadays say, talking to the government reports, okay, from this point, maybe in 2010, it is stagnant in waste management from 2010. So still 20%, 25% are burning, and 16% are going to landfill. It's not changing after that, 2015, 2010 around. So that's why we faced so many the waste problems recently, even though they are putting new law, use the economy, the circular economy law, or something like that. So what I'm saying is, we have to go further to develop more waste to energy facilities to get around zero of landfill, maybe zero waste. Okay. Okay, next one. So, I got retired around 3 years before, so I played a role to put together all our members, the waste energy members, to do this. So I made a waste energy policy technology forum, and then we have to shout to the government to go right way. So we did. Also, at the same time, we have to, tell the public, okay, this is a safe technologies ready or something like that. So I quote this from the EU. So as you may know, we are here now, 14/24/62. So 14, the landfill, incinerator, 60%. So like advanced countries in Europe, they got almost zero of landfill, and then recycling around 60%. And that means waste energy another 30% or so. That could be one of the indices to where we have to go. So I used to say we have to go that way to achieve the circular economy of the net waste. Yeah, there's a summary kind of things why we do, we utilize the waste energy. So further, even though we did good up to now. The next one. Yeah, this is a summary of my talk. Okay, we did, good with the, utilizing waste energy, but last 10 years in Korea, maybe 10, 15 years, the governments or, sectors, they do not, realize the real load of waste energy. Also, as you know, a lot of incinerators were built 1990s, 2000. So it's coming, 30 years now. So it's a time to come to replace. So aged incinerators, that has to be replaced with the proper technologies. And also, but governments put this kind of goal. All the waste must be pre-treated before landfill. This means what? It has to be burned. But they are not supporting. They just put one line in the law regulation. So, yeah, that means what? Our Korea, maybe waste energy industries will be coming up. Okay, so like Seoul metropolitan cities, they are burning around 2,000 tons of waste every day, but they need another 1,000 tons of waste must be burned. So recently, I was working for them to designate one site, new site, but a lot of objections there, even though they had experience, they knew the incinerators just of their residential area in the big apartment next to there's an incinerator, but still objections. So the policy or the governmental strategy must be moving. Also new one, like a CCUS with carbon captures, and also new technology like as I introduced, pyrolysis, gasification, renewable energy development from the waste, that must be done. Okay, next. Yeah, this is just my recent activities. I do biomass to make produce oil. So I work with one of the Vietnamese province for put that I told you 20 tons per day units in operation in Korea. So we'd like to put that oil production facility into one of the Vietnamese province. So nowadays, after making oil, that oil can be upgraded to another transportation oil or aviation oil. So we are doing research on that. Yeah, technically it's okay, possible, but they're commercialized. They're still working on. Okay, I think I'll skip the next slide. Okay, thank you very much for your attention.
Thank you so much, Professor Shil, for your presentation. And I'm gonna get to the attendees if you have some questions. Professor Wang.
You mean after producing SRF, how much we are selling? I think that was around US dollars, maybe $100 or several hundred dollars a ton. Yeah, 100 or 200. It's expensive. But the power company is willing to buy. Nowadays, the power company, cement kiln, also pyrolyzing companies, they are fighting, to buy them. Coal. I don't have the number in mind. Yeah.
So is there any questions from the audience? Any more questions about the presentation?
I have a question.
Oh, okay. So we're gonna give the, I'm gonna get back to you, dear Enrique.
Okay. Thank you. Just I have a small comment regarding the extended producer responsibility, EPR. We have the impression that the cost is usually borne by the producer, which is not true. The producer is reflecting that on the consumer. So we as a consumers paying that, just to highlight this fact.
The price of the product will be going up. So
thank you.
Yeah, that's true. But system, the application is a good right way. So also we can get reduced. Also we have a good, such as e-waste, electronics, computer, TV, is well collected. It's collected by free. I mean, the public don't have to pay. Just call them and then they will collect it. And then they will recycle it. So we have about 10, 11. I'm working for the association to distribute those money to the recyclers as the board member. So the system is good. Of course, that will just to go to the consumer, right?
For PRO there?
PRO?
The Product Responsibility Organization who is managing the APR system.
Right, APR system.
Which type of PRO there? Is it
we call it
governmental or
union?
Private body?
Not private, but the governmental, by the law, but non-profit organization.
Non-profit.
It's a union. We call it union.
I see.
Yeah. So
under the umbrella of the government?
Sure. Yeah, by the law. Strictly. So every year, the government and this association union has talking in the beginning of the year. Okay, you do this much. Next year, it's a certain price, and then it will move to the. Of course, that union will be is consisting of all big company like Samsung, Dow, LG, all other importers.
Those are the
we're collecting money from those companies.
Thank you.
Okay, thank you. So last question for from Enrique.
Thank you, Reda. Professor, could you explain how do you finance those waste to energy projects in the country? Are they financed by the government or they are given to private companies? What is the way of financing those projects?
You know, I think governmental play is very important in managing the waste, especially. So law has been, enforced by the governments, but also same, especially in municipal waste in Korea, it's totally managed by the government. Government has a responsibility. I mean, local government as well. So they put money, so they have to calculate how much tipping fee they have to get. So yeah, most of money is coming from government, local government. Of course, constructions, operating will be done by private company, but yeah, government do that.
Okay.
Thank you.
Thank you so much. Thank you so much, Professor Siu. So yeah. So now we're gonna have a break for 15 minutes, and then we're gonna go back for the second session of the morning. 10 minutes. Okay, let's go. 10 minutes.